Well, I half expect the aliens to bust through the back door right now. I don't know. I was going to ask my guests to start, how excited would you be if aliens actually revealed themselves to us?
Oh my God, that's what I've been hoping ever since I was like 6 years old. Like I used to stare up, lying on the grass, looking up at the sky and hoping for the Starship Enterprise to beam me up and meet a bunch of aliens. That was my fantasy. So yeah, that's what's kept me in this whole science game all this time.
Yeah.
Yeah, myself also. I did the same. I used to wait for the ship to come and reveal that I was actually the prince or whatever, the heir to the galactic throne. Never happened. But yeah, that's sort of, I just have this feeling like, please, before I pass into the next world or whatever it is, answer this question, this fundamental question, which is 2,500 years old. To know the answer to that question is like kind of...
So I do want to, before we get into odds and probabilities and likelihoods and scientific analysis, I just want to say, do you take seriously the scientific proposition that there is other life in the universe? Adam.
Yeah, absolutely.
David.
Yeah, how could
lightning
you not?
round.
How could you not?
And do you take seriously as a scientific proposition that there might be technologically advanced civilizations in the universe?
Absolutely.
100%.
Okay, so that's where we're starting from. So we want to make that part clear before we debunk some of your favorite conspiracy theories.
Before you make you feel bad, sorry.
So I do, before we launch into the depth of the astronomy, begin by setting a sense of the scale. So here's our home planet. This is a tiny, tiny fraction of the human-made satellites around our planet. There are tens and tens of thousands of satellites around the Earth, and we are a technologically advanced civilization, right? But here we are.
Yeah, this is one of the things we could potentially look for. This is, there's got the Starlink system going up now with tens of thousands of satellites. There's actually like a little glint that comes off those. It kind of bothers astronomers a lot when we use our telescopes and look up at the ground and we look up into the sky. You see these glints and it makes these satellites very bright. But that same glint, in principle, could be detectable to another civilization. Similarly, if we built this kind of Clark belt, which has been written about Arthur C. Clarke, the idea of these geostationary satellites. We have a whole bunch of those. We put a lot of those there because they let you look at the same patch of the Earth as you orbit around. And so you might expect us to have an excess of material there if there's an advanced civilization. And naturally, there is no reason why material would coalesce at such a distance. It would be a dead ringer that somebody had put that there in order to look down at their planet.
So right away, we can look at ourselves and ask, what would somebody looking at us see? And here we are, we're around this star which just faded from view, which it blinds us, though, from afar. Adam, could you possibly see? It's so hard to see us.
Well, if we were having this discussion 50 years ago, we'd say like, oh, maybe only with radio if somebody was pointing a radio telescope at us. But now our telescope technology has gotten to the point where we can actually see planets like Earth through the light that can actually pass through the atmosphere, starlight that passes through the atmosphere, and see the chemicals that are in that atmosphere. So now actually from distances with our own technologies, from distances of 140, 100, 200 light years, we could find an Earth-like planet that had technology on it indirectly.
So again, just to get the sense of scale, we are around our sun, which is a very ordinary yellow star. We have 8 planets. Let's not discuss Pluto's demotion.
Let's not go into Pluto.
Very hotly,
sorry, Pluto.
Hotly contested.
Strong feelings on that.
Strong feelings. Some 200 plus moons in our solar system, lots of tiny objects. Now, right now we're looking at the entire galaxy. How many other stars are there in this galaxy? I'm actually going to throw this one to David. How many others?
We actually don't even know exactly. I mean, this always kind of blows people away. You'd think by now we'd have a precise number. It's probably of order of about 100 billion or so, but it's kind of impossible to count them all up because of that bulge. So if you look at this image, there's this bright bulge in the center, and obviously we live on one side of that bulge, and you can't really see through it, right? Because it's just so bright. So it's very difficult to calculate exactly how many there are, but there's probably 100 billion, and that is pretty mind-boggling when you think about it. We think on average, every one of those stars has planets around them, and Earth-like planets. We're not 100% sure how often they are, but there seems to be good evidence that they're at least not a totally rare phenomenon.
When was it for, oh, Adam, please.
I just want to
jump in.
amplify that point so people understand, right? So, you know, when I was a graduate student back in the late 80s, we didn't know if there were any planets anywhere. That had been an open question for 2,000 years. You can see the Greeks beating each other up about it. Now we know for a fact that every star you see in the night sky hosts a family of worlds, which is stunning. Right? And then, if you count up about 5 of those stars, one of them has a planet, an Earth-like planet or a planet in the habitable zone, where we think it's possible for life to form if the conditions are right. So that transition from just 1990 to now, where we now know that there are planets everywhere, every star has planets, multiple planets, is perhaps one of the greatest revolutions.
Can I
in
slightly
science.
correct it? It's actually not true that every star has planets.
Okay.
It's that on average, every star has at least one planet. I think when you look in the galactic bulge, actually, there's probably lots of planetless stars because the stars are packed so close together. It's probably not possible to have planets there.
But here we live, and New Yorkers always hate this, out in the galactic suburbs. And where it's nice and calm and there's some space and we're between the arms. So we're not in the center of the galaxy, but it is very likely that there are more planets than there are stars.
Oh, absolutely. And even free-floating planets as well. There could be tons of rogue planets.
Who got kicked out
That's
of
a great
there.
term, rogue planets.
Yes.
Sounds like out of Star Wars, doesn't it?
Okay, so that leads me naturally to our next topic, which is flying saucers. So, you know, it's a little awkward that every time there's a sighting of some kind, it shadows our own technology, and they're like unimaginatively human-like in both mind and spirit, you know. But, I mean, it's possible. So tell us about Roswell.
Roswell. Yeah, well, Roswell actually, maybe even let's go to the first sighting, the most famous sighting, which was 1947, and it was a guy flying a plane over in Washington State. And the really interesting thing about this first sighting was, you know, he saw 9 or so lights in the sky, tracked them, landed, and then told his story. And the story he told was about things that looked like kind of flying bat wings. You know, that's what he saw. But the reporter misheard what he said and said, oh, flying saucers. He never saw a flying saucer. And yet it got reported as flying saucers, and within 6 months there were 870 reports of flying saucers. So I think there's a great deal to be gleaned from that story.
Right. Before that, it would have been gods and fairies and deities, burning bushes, all this kind of stuff. So there's always something culturally that people would see something weird and latch on. I'm going to insert God of the gaps here.
Right.
Yet you do take seriously the possibility that in our galaxy, with its hundreds of billions of neighboring planets, that there could be other technological civilizations, and we'll get deeper into that. So you don't dismiss it out of hand. If there's a case, you will take it seriously.
Yeah, I mean, one of my colleagues, Ravi Kapparipu, made a great argument about this, and he said, look, when we do astronomy, a lot of us are looking for technosignatures. Me and Adam are involved in that search. And so we're looking for radio signals or satellites around other planets. And then if it's in the solar system, if it was a starship passing through the solar system, we would still call that legitimate science and we'd still call it an astronomical search. So why is it when it enters the atmosphere, we suddenly say, hold on, this is no longer science? Like we can't delineate there's some boundary where something suddenly crosses and it's no longer science. So we are definitely interested in detecting. That would be phenomenal if we detected a convincing UFO. I don't think we have the convincing data yet.
I think that's really the main thing, is to understand that, I think we might even show a couple things about this, is that the problem with UFOs is the history of it. And there's been so much conspiracy mongering and so much sort of anything goes as evidence. Like in science, we have what we call standards of evidence, and we're mean to each other. Like if David publishes a paper, I love David, but if he publishes a paper that makes an extraordinary claim, me and all of his friends are going to tear him apart.
I already corrected him once, right? So you know we do this.
Because that's what we expect from each other. Like we want to know so badly that we're really mean to each other. And the problem with UFOs, it's been like, oh, anything. You know, your grandmother saw a light in the sky, aliens, right? And so, you know, we're both all for open, transparent investigation of UFOs as having something to do with, you know, alien life. But the problem is nothing that exists today comes even close to the standards that we'd have to hold ourselves to if we said, oh, we found alien life on another planet.
Yeah, so it was very interesting that Roswell probably was a cover-up, right?
That's the best part.
Right, so they were probably covering up some technology that the U.S. Air Force was developing, and this backlash over the many years led to this transition quite recently to renaming UFOs to UAPs, unidentified aerial phenomena, or sometimes you'll see on the government websites unidentified anomalous phenomena, and then trying to be more transparent about the investigations. Obviously, some of it they're going to keep classified, because some of it probably is classified information. But I thought it would be interesting for us to look at a specific case study, just to be honest about what is out there. This is one of the most interesting cases. Does anybody want to take the lead on this, or I'll just launch it in 2015?
Yeah, well, so there are these 3 videos which were published that the New York Times picked up on, which get reprocessed over and over again. These were Navy pilots who were filming, saw things. Oftentimes they didn't see it themselves; the instruments saw them, and that's a really important thing to understand. And so these things have been sort of the focus. These 3 videos have been the focus of a lot of attention. And there's lots of problems with them as scientific evidence. And so wild claims have been made that these things, you're seeing things that are moving at impossible speeds, that are making right turns at, Mach 50. But, one of the biggest problems about this is, as for science, is that, we don't even know what these instruments, these cameras, flight cameras, were they recently refurbished? Was there new software? You hear voices. I think we're going to hear the voices soon. We don't even know where those voices came from. This is pre-digested data, pre-edited. There's nothing really you can, as a scientist, you can do with this. It's just, it's not the way we do science. And most importantly, scientists have looked at this. And for example, one of these where people were claiming it was moving at impossible speeds, just doing a little bit of parallax with it, basic scientific way of evaluating data, showed that it wasn't moving at 30,000 miles an hour, it was moving at 40 kilometers an hour, and it was at 30,000 feet, and exactly the kind of thing you'd expect from a balloon. So these things just really don't even come close to standing up to the kinds of scrutiny you need to be able to make an extraordinary claim like we're being visited by alien technology.
Which you would love. If it
We'd
turned
love,
out to be
if it was true, oh my
Okay,
God, please let it be true.
So let's listen to this, because it is actually quite chilling, and supposing it is real, they are affected by what they're seeing. You ready to listen?
Let's do it.
And David, I'd love to hear your thoughts on this.
Dude, there's a fucking drone, bro. There's a whole fleet of them. Look on the ASA. My gosh. They're all going against the wind. The wind's 120 knots from the west. Look at that thing, dude. That's not our LNS though, is it? It's not. That is the LNS, dude. Well, if there's like... Look at that thing. It's rotating.
Yeah, it was definitely chill. I remember when I first saw that, I was like, wow, that's very intriguing. But upon more careful analysis, you realize there are alternative explanations. I think what we really want with these is an unambiguous evidence. The thing to remember with these cameras and these images that have been taken, there's about 28,000 pilots across all military branches in the United States. And they fly on average about 200 hours per year. So that's 5.6 million hours in the air every year that these pilots are flying. So if there was 1 in 10,000 of those hours you saw something strange, that was your false alarm rate of a UFO. In science, we always want a false alarm rate, your false positive rate. That would lead to about 560 UAPs per year, which is actually about right. That's about what they see. But even a 1 in 10,000 error rate would be extraordinarily optimistic for a human being, even with all this equipment. That's flying 413 days continuously, non-stop, and not making a single misidentification of what's around you. Right. We're human, we're fallible, even with instrumentations, we're going to make errors. So if we want to turn this into science, here's what we need to do. We need to know how often do pilots with this instrumentation erroneously make claims of things where we know for sure in a control circumstance there is no UFO, and then is the number of these events in excess of that which you would expect given that rate? And we just haven't been able to calculate that because we don't have all this information. They won't give it to us.
Well, there was something like 1,600 cases that were recently analyzed, that were released by both the government, NASA analyzed, and of the 1,600, 21 remain anomalous, and something like 70% were balloons. 15, which I thought was a large number of balloons, you know what I'm saying? But I
It's only
assume they
getting
mean
worse.
weather balloons and not like party balloons, you know?
Drones.
And 15% drones,
Right.
some birds, a couple of planes. But Adam, I love something you said in your book. You were like, why do aliens suck so bad at hiding?
Yeah, that's one of the things. First, I want to say, like, it's great that the pilots, if we're changing the culture where the pilots can come forward, you know, because there was a stigma beforehand, which is actually a stigma that really affected SETI. Like, SETI never had funding.
The search for extraterrestrial
Search for
intelligence.
extraterrestrial fun. You know, the scientific search for life was really deeply, you know, adversely affected by UFO culture. That's been well documented. But so it's great now if we can have pilots can start coming out and saying, hey, I saw something, and we'll record it and we'll put it, and that's the only way we're going to be able to do what David was talking about. But yeah, the main thing that happens with UFOs is that it always becomes a science fiction story. It's like, well, they're here, but they're hiding because they don't want us to know. You know, I saw lights in the sky. And it's always like, well, wait, if this is an advanced civilization that could cross the incredible depths of space, which we should talk about, how distant the stars are, and yet somehow they get here and they can't turn the off switch on the lights. I call it the high beam argument. Like, what is it, the teenagers? You know, they're like, hey, we're joyriding with these things. So it just doesn't make sense that these super advanced species, which want to stay hidden, are so bad at it. Like, you know, why don't they just either land on the White House lawn and be like, hey, we're here, you know, or,
Stay
you know,
hidden.
really be hidden. And somehow they're always, you know, they're just not really good at staying hidden. So it just ends up being, you have to tell so many stories that sound like a science fiction story that it kind of really stretches belief.
Yeah, I do want to say, like, when you talk to UFO proponents, they have a way around that. They'll just say, oh, you know, we don't know their psychology, we don't know. So it is hard to convince someone on the basis of sort of psychological arguments of what they would do. For me, the more problematic issue is not only this false positive rate, but the fact aliens can explain everything. Like, there's nothing you can't explain with aliens. So, you know, the reason why your curtain blew last night was it the wind or was it aliens? It could be aliens. What, you know, why did this cup fall over onto the floor? Oh, that must have been aliens that did it. So aliens, it's such an it's a unique hypothesis in science because there's basically no other hypothesis in science that can explain everything. And that's very dangerous. And I think that's why it makes it very precarious for us. And we do demand extraordinary level of evidence to support it because it is such a overly malleable hypothesis.
Well, let's take the more serious suggestion, which is rooted in actually looking for astronomy that convinces us that there are exoplanets out there. There are planets outside of our solar system. This is a kind of meet your neighbors here. We're about to see our own solar system recede. And what is so stunning about this is just what's in our solar neighborhood. Now, Adam addressed this, that in the 1990s there was this miraculous discovery that there were other planets out there. But, I mean, David, it's stunning what we've found. I mean, the abundance. It's not just a statistical claim that there are lots of planets out there. We are seeing individual star systems and identifying them. They are our neighbors. These little circles around all of these stars right in our galactic neighborhood, our backyard, all have planetary systems. How far away are some of these, for instance?
Thousands of light years. Yeah, that's about as
Which is
far as we've gone.
close.
Which is actually pretty close because the galaxy is about 100,000 light years in diameter. So we're still just in our solar neighborhood really when we're looking at these exoplanets. But every generation of telescopes we're going further and further out. So we're building this census. We have about 6,000-ish exoplanets discovered so far, but that's just the tip of the iceberg.
And they're right around us.
Yeah.
So we're extrapolating that there are hundreds of billions in the galaxy, but right around us, we're literally saying there's one, and we're counting to 6,000 in our backyard.
And if I could, one thing that for people to understand, there's the question about life, which we're going to talk about, whether it's, just microbial life or intelligent life. But even before we get there with these planets, David may disagree with me on this, but, we can think about all these worlds, right? These worlds where things are happening, right? I don't think it's an irrational or exuberant claim to say that some of those circles you're seeing, there's snow falling. And there are canyons where the wind is blowing across. And there's oceans that are lapping up, waves on shores. I feel like that you don't have to really push very hard to be like, no, that's actually happening. So, life, that's a big open question, but snow-covered mountains, oceans, yeah, that's happening right now billions of times, or at least hundreds of millions of times.
So tell us what kinds of planets we're discovering. Like
It's
rocky.
incredibly diverse. Yeah, here we've got an example of one of these lava worlds. So there's a lot of planets which are found so close to their star that kind of the same way that the moon gets tidally locked to the Earth, we only see one side of the moon. These planets are so close to the star, they get tidally locked. So that means in this case, the planet's so close in that one side is being scorched, actually melts into magma. There's a magma ocean. And the other side is kind of crystallized into something harder. But this is just the tip of the iceberg. I mean, there's so many strange planets out there. There's, these sub-Neptunes is kind of what's puzzling many astronomers right now. These planets which live in between the size of the Earth and Neptune. We have no such planet in the solar system. We have no idea what those are. Are they ocean worlds? Are they super-Earths? Are they miniaturized gas dwarfs? We don't know. And this is what makes it exciting for me as an astronomer. I love it when there's stuff we don't know. And that's actually what drew me into astronomy in the first place, is those unknowns.
Mm-hmm. So imagine some of these ocean worlds, for instance. We think they don't have land as we do above the water. Is that something where it's conceivable that there could be combustion? I mean, what kind of life are we imagining on these ocean worlds? I mean,
yeah, this is a really interesting and very open question. So we've just talked about these things called sub-Neptunes, right? And I think it's really interesting that those are the most common type of planet in the universe. The most common type of planet in the universe is exactly the kind we don't have in our solar system. And recently there's been this recognition that some of these worlds could be what we call Hycean worlds, hydrogen atmospheres with 700-mile deep oceans. Remember, the Earth's deepest part of the ocean is 6 miles, right? So like in a world like that, is it possible to have the kind of chemical exchange from the rocky bottom up into the ocean that happens on Earth, which was really important probably for the beginning of life on Earth? Is that possible there? In a world where it's only oceans and there's no land at all, can you get the right kinds of, as we said, the beginnings of life? And then when it comes to technology, this is a paper that we just recently did, where we sort of asked the question that if you don't have that kind of cycling, is there any way without combustion, can you get technology, right? If you're underwater, you can never do metallurgy, right? So it really opens some deep questions about where intelligence can form.
And of course, even before all of that, you might not even have the conditions for life, because if you don't have any substrate, you're just in a 3D volume, you've diluted your organic molecules so much, it may become extraordinarily unlikely that you get the complexity to build up to start life in the first place. You may need 2D surfaces just to get life going.
Now, we are the single example that we're sure of. And do you worry that some of our assumptions about the universality of chemistry, the universality of biology, the universality of evolution are biases that we can't see past? Or are they, as I feel about the laws of physics, transcendent, which is also magnificent, a magnificent power, if in fact evolution, just to start there, is universally applicable? I don't know.
I mean,
what do you think?
we have the story of the Earth, and we try our best to use that as an example, but of course we don't know how far it extends. It is surely, at least at the very minimum, one instantiation in which way life can begin on a planet. But it doesn't mean it's the only way. Sometimes you'll hear, NASA used to have this thing called follow the water. I think they still probably have it for their searches for life. Follow the water, because wherever there's water, that's where on the Earth you find life, and all life on Earth requires water. But then I'd often get, people push back that and say, well, what about ethane or methane, or what about, silicon instead of carbon? Like, why do you, physicists and astronomers are so set on things being just the way they are here? And I think there's a pragmatic answer to that. It's that, how am I supposed to look for life in a completely alien type that I don't even know how I'd recognize it? At least I know I think, how to recognize life that we have on the Earth. So it's just the obvious starting point. So sometimes it gives the sense that we're extremely narrow-minded, but it's more just a decision of pragmatism. Like, let's just start with something we can all agree on, and then we'll move to the crazy stuff.
Right.
Yeah, and I think that's true for technosignatures too. When we're looking for alien technology, we start with what we have, chlorofluorocarbons in the atmosphere. But I think this brings up a really beautiful point. So astrobiology, this field of astrobiology, didn't exist when I was a young scientist. It's only been because of the exoplanet revolution, et cetera. And now technosignatures, the search for technology, NASA wouldn't even fund until we were both at this amazing 2018 meeting. And now that astrobiology really is kind of the frontier of astronomy, and we can talk about why we know that's true, it really forces us to go back to these assumptions. And now systematically, this is what's so exciting, systematically, we're starting to ask these questions about the extent of life, what kinds of different, how different life might be, how different sentience might be, alien minds, in a way that we didn't have the funding, we didn't have the generations of graduate students to pursue this question systematically. And now, this is why astrobiology is so much more than just the question of life out there. It also turns right back on us and about what life is, what sentience is, and also the future of our own civilization. They're all part of, kind of astrobiology in a way.
Yeah, Jill Tarter used to say SETI is a mirror. It's a mirror. SETI is the search for extraterrestrial intelligence. And whenever we look out and we say, okay, we should look for planets undergoing nuclear war, because in the 1970s, it felt like there was a risk of that happening. And so astronomers were seriously considering that as an obvious technosignature. But every time we think about a technosignature and like satellite systems that we're building now, it is really just a reflection of ourselves more than anything. I mean, you go back to Percival Lowell in the 19th century, he was looking for canal systems on Mars, because to him, that was the obvious technosignature. And now it looks laughable. And I think in 100 years, we'll look back at the things we're looking for and think, that was ridiculous. What, satellite systems? What are these guys, dinosaurs? Like, what are they doing that?
Percival saw the lava flows. We're talking about the Martian canals, the canali, right? And suggested that was an evidence of irrigation, which was the height of technology,
right?
Which is exactly what you're saying.
He's a great example, I think, of someone who was preloaded by his biases. He wrote in his book, the certainty that there's life on Mars is as certain as that gravity exists. So even before he put his eye to the telescope, that's what he thought. And on top of that, he'd been told by the ophthalmologist in Boston that he had the greatest eyesight he'd ever seen. So he was preloaded with these two things. One, whatever I see is real, because I have the best eyesight ever. And two, of course, Mars has aliens on them. And so what do you know? The first time he looks through the telescope, aliens. And for 20 years, astronomers were trying to chase that ghost.
Adam, you wanted to add
Yeah,
something?
I just want to say that one of the most interesting things, at least for me in this field right now, is the idea of agnostic biosignatures and technosignatures, right? So we have this bias. We're starting off, with these human biases about or Terra-centric, Earth's history. But now there's a real push to start developing biosignatures and technosignatures, which are basically signatures in the light from an exoplanet that will tell us whether there's a biosphere or a technosphere, a technological civilization. And we're starting to think about ways that take us beyond our own history. So using things like information theory, that's something that I'm really interested in. Using something like network theory, looking for ways of investigating the signals we get from light in a way that really has nothing to do with assumptions we've made and just looks for kinds of anomalies or patterns that we wouldn't expect from anything we call life. We can make these very general definitions about what life does and say like, okay, this is something, or at least let me put it the other way. We know what planets do, geospheres, and we can say this is something that would happen on any purely lifeless planet. So I think the agnostic biosignature and technosignature development of that, which is very new, holds a lot of promise.
Well, let's talk about some of the biosignatures, because I think there's this very interesting point that if somebody were looking at us, it's all we can really be sure of is this one example. What does this one example look like? And if somebody were to look at us, in some sense, we're in a kind of disequilibrium chemically, right? Because the Earth doesn't want to have exactly these proportions of carbon dioxide and oxygen. These are replenished constantly by life, either human, in the case when we're having ramifications on our environment, or just plant biology. And so we're looking in some sense, and I think, Adam, you made this point very interestingly, that we're looking for a disequilibrium.
Yes.
Something that's very difficult to maintain in the atmosphere naturally. And so when we're looking at these planets, can we resolve them? Can we see them in all this glory that I've been showing with these NASA animations?
We can't even image more than a pixel in the very, very best cases. So usually these planets are nothing more than a blob of light. But typically our methods are pretty indirect. We get some sense of what's in the atmosphere of these exoplanets. Oxygen was for a long time thought to be a great biosignature, because if you took away all the life on Earth, the rocks would oxidize within, I think, 2 or 3 million years or so. So the oxygen has to be maintained, has to be produced, as you say, Janna. But now we realize there are ways of producing oxygen without life. So for instance, ultraviolet radiation from the sun, especially if you're around one of these other types of stars that can be more violent than that, will break up water into oxygen and to hydrogen. And the hydrogen is so light that our planetary atmosphere, our planet's gravity can't hold on to it. So the hydrogen just escapes into space. That's why a helium balloon goes up into the sky. So it just escapes into space. And so you're left with the oxygen. And so that is an example of a kind of disequilibrium, but it's not life that's doing it. It's an astrophysical or even sometimes geophysical process that's maintaining it. So in terms of information, I like this idea. There's been a revelation I've had with this assembly theory idea that's been getting a lot of traction. And the idea is, what does life really do? It makes complexity, whether it be technology or organic life. It builds complex molecules. And not only does it build complex molecules, it builds a lot of them. So those are the two things to look for. Something that's very complicated, and there's a lot of that thing. And whenever you have that combination of those two, that's something that you don't get without life.
I mean, do you think we could ever trust the biosignatures, or will it ever be conclusive?
I think it's a lot. I mean, one of the real pushes right now, again, it's so fascinating to watch this field mature, right? Because again, in 1990, you would have said, like, what can we even do? What can we even say? Like, this is always going to be, we're never going to have any data. And now we're starting to actually get data. We're, from like even the James Webb Space Telescope, we're getting actual spectra from planets that we can analyze. But also the sophistication of our understanding of how to evaluate your question. So one of the frontiers that's happening is the idea of context, right? So David brought up this idea that, okay, oxygen by itself will not be a biosignature. But now you got to look at the planet, because that's really only true of what we call M-dwarf planets, planets that are orbiting small stars very close to the star. That's the only way you're going to get that kind of non-biogenic high oxygen level. If you saw it on a planet that was orbiting further away, that would probably be a biosignature. But now we have to start looking at the entire planet. We have to look, well, what kind of planet? Is it terrestrial? Is it not terrestrial? What are the other clues? What are the other kinds of chemicals in its atmosphere? What can we tell about its geological history? So right now up at the University of Rochester, we have a big laser. It's actually a giant fusion laser. And we're using it to squeeze silicon down to like super high pressures to see what would happen inside a super Earth, to ask whether or not, would these things have plate tectonics, which we think may be really important? Do these things have magnetic fields? So I think, I think what people should understand is if we found a biosignature tomorrow, that would be the beginning, not the end.
Well, to add to, we actually have found biosignatures, and it's kind of controversial because there's been numerous claims already. On Mars, there was methane, which people got excited about a while back. There was
Venus.
Then phosphine on Venus, which people got excited about. And now just a few weeks ago, we had DMS, dimethyl sulfide, on an exoplanet called K218b. So we've actually had numerous instances. And in the previous two, the community have largely assumed, or come to the conclusion, I should say, that this isn't very convincing. Either the evidence isn't particularly significant, or there's other ways of producing these molecules. In the very recent case of K218b, I guess the jury is still out. We're going to get more data with Webb, but that's what makes it science, that we can point the telescope again, get more data, and test this hypothesis. And similarly, we've been doing that with Mars and Venus as well.
So I feel very comfortable saying things like, I think chemistry is universal. I think math is universal. I mean, we can get into philosophical arguments, okay, but that's like for Saturday night, at the end. Like basically Monday through Friday, I feel really confident about it. And I do also about the laws of evolution, the periodic table. So it's not, though, that easy, though, to go from that to say, well, I think plant life is universal. or the animal kingdom will always make, bilateral symmetries. So what do you think about how, even if we take that for granted, that evolution is universal and chemistry is universal, what are we imagining for life on other planets? Is it silly to imagine a bipedal, two-eyed? Is that crazy, or is it convergent evolution?
I think that's too convergent, right? So one of the funny things about all the UFO stuff, it's always, a little guy with a triangular head and two eyes and, and shoulders. And I just, I think while evolution we can think is universal, because it's really just a logic. It's a logic about who wins if you're well adapted to the environment. So things like sticks for, like some jointed limbs if you have to walk along a surface, yeah, we can expect something like that. But, whether you get 15 joints or 2 or that is going to be contingent, right? So evolution works on accidents and it works on physics, on the relationship between what the physics solutions to the problems of survival. So asking for our forms that have happened on Earth, that's asking for too many accidents to have run the same way. But again, thinking that we should expect wings, like wings have happened so many times on Earth, that may not be so weird. But I always like to say we should expect to be surprised and we should expect to be grossed out.
Yeah, I'm actually, to come back to your original question, I'm open to the idea, this is kind of controversial amongst my colleagues, but I'm open to the idea that this could be it. That, maybe chemistry, I agree, is everywhere, and math is everywhere, but that doesn't necessarily mean life will happen everywhere. So as a scientist, I think it's important that we remain open-minded to both possibilities. We don't want to become Percival Lowell and decide we see life everywhere we look. In terms of, I guess, the example that Adam gave, which I totally agree with, really highlights how unique this hypothesis is. Once again, we are looking for something, but we don't know what we're looking for. Right. We have no idea what we're looking for, but we're trying to look for it. And that is kind of odd for a scientific experiment. So it puts us in a very difficult position. I think the most useful connection to evolution I see is actually thinking about the future of life on Earth. We've had one evidence of a technological species on our planet. Adam has done work thinking about whether there could have been previous technological species. We kind of assume generally that isn't true. And similarly, there's still almost 1 billion years left of this planet to be habitable. 1 billion years, that's a mind-boggling number. I mean, think about the dinosaurs were kicked off 65 million years. That's 0.065 billion years. It's nothing. So there's so many opportunities for mass extinctions, for new civilizations to rise and fall. This planet could have many, many descendants on it of future civilizations.
Well, I think that leads us to the famed Fermi paradox, who in 1950, the renowned particle physicist who at a casual lunch with friends said, "Where is everybody?" Right? And he meant advanced technological civilizations. So where is everybody?
You have an opinion on it.
Yeah, okay. So the Fermi paradox, like the Drake equation, which we haven't talked about, but like there was this early era of the search for extraterrestrial intelligence, or the early era of thinking scientifically about life and intelligent life in the universe. And the Fermi paradox was one of these ideas that these founders, this small community of really bold thinkers, kind of got stuck in their head. Like, well, why? I mean, what Fermi was really asking, why aren't they here? Like, why haven't they already? If there's all these technological civilizations that can travel through space, why aren't they here now? And that was one version of what became the Fermi paradox. The other one was what we call the indirect Fermi paradox. It was, well, and you hear this all the time, we've been looking for years and we haven't seen anything. We have all these telescopes, and how come we haven't seen anything? And that, both versions of the Fermi paradox, I'm going to argue, are not paradoxes at all. But let me speak to the second one, because you hear that more. And it's the idea that, every night, astronomers are taking their telescopes and they're searching the heavens for alien life. And that's just not true. And it's not true for the most mundane of reasons: money. There's never been any money for SETI. Like, we haven't looked. A colleague of ours, Jason Wright, did a study where they counted up all the SETI searches that have ever been done, all the times people have looked for aliens. And their analogy was, okay, if the sky is the ocean, how much water have we already gone through looking for, say, fish, if aliens are fish? And it turns out a hot tub. right? So if you pulled up a hot tub's worth of water out of the ocean and looked and said, oh, there's no fish, therefore there's no fish in the ocean, right? It just doesn't make sense. So my argument, I really think that this idea of the Fermi paradox, that we've looked and we haven't seen, or why aren't they here now? For the first one, we just haven't looked. And for the second one, there's so many ways around it that it's just not, the Fermi paradox is just not a useful tool, conceptual tool. That's my take.
Yeah, I'll come on the first part, that the direct one that you alluded to there. So the direct Fermi paradox, it was Michael Hart wrote this paper in 1975, and he called it Fact A. And Fact A is that the Earth has not been colonized by some roaming alien civilization. That appears, at least, to be true, and sort of the least incontrovertible thing you could say. And it's probably, many people cast it as the hardest evidence that we have about alien activity. And that might sound a strange thing to claim as a limit, but it's actually not that difficult to imagine a civilization roaming across the galaxy and actually turning everything into computer substrate if it was some roaming AGI or something. Even at Voyager 1, Voyager 2 speeds, which are like 10 kilometers per second or so, very, very slow speeds, chemical rocket speeds, you could cross the entire Milky Way in its history 2.5 times over. So there's, even at the most pitiful speeds of human rockets, there has been plenty of time for even very slow vehicles to have basically visited every star, every planet in the galaxy. So my kind of hot take on Fact A, I don't know if I've told you this one before, but it's probably not as useful as we think because of something called the weak anthropic principle. So the fact we are here, and people say, well, therefore aliens have never visited, this is a strong data point. Maybe that's not as useful as we think, because of course we couldn't live on a planet where that had happened. It's impossible for us to live in a galaxy where there was a roaming galactic civilization. Maybe 99.999% of galaxies, this is what happens. We would have to live in the 0.001% of galaxies where that didn't happen, else we wouldn't be here. So this is an example of what we call the weak anthropic principle. So it just kind of dilutes the power of that statement a little bit for me. It means it's maybe not as useful a constraint as we normally think it is.
There is also a suggestion that there are great filters, which is famously cited as a resolution to the paradox you don't believe exists at all anyway. But one of the possibilities is that any technological civilization, by manipulating their environment, faces a climate crisis, inevitably. And that is just an energy argument. We are trying to harness resources which are limited, and we're doing so immediately without the foresight of some great design or plan. Do you think that a climate crisis is inevitable for any technological species?
Yeah, and it was the topic of my book before the last one, The Light of the Stars. And actually, yeah, I won't tell the story of how I got to that, but my thinking, because I've known, from early on, one of my first jobs was in climate change at the Goddard Institute for Space Studies, right, back in the mid-'80s, before anybody had heard of climate change. So I've been thinking about climate change my whole life. And at some point I recognized that climate change, which gets so politicized, and it's a astrobiological question. It's a question of planetary evolution. And any species that reaches the point where they're harvesting a significant amount of the energy from the planet is going to have a feedback. Like if you could have landed on Earth during the Roman time, you would have looked around and been like, climate change is coming, right? And so, and we did a bunch of papers on this. We did some modeling on this. I would argue that on the way, on the ascendancy of your energy use, you are going to push back on your planet. You should expect that to happen. And then the only question is, are you smart enough to be like, oh, I need to change energy sources? Like, that's all there is to it. But I think that Anthropocenes are maybe quite universal. And it's just, are you smart enough to recognize it?
So Anthropocene, the era in which human beings have a very significant impact on the actual environment, biology, and ecology.
Yeah, I think that they're, what alienocenes, that any civilization that is harvesting a significant fraction of the energy that their biosphere is using is going to push back on that biosphere. We should just expect it.
Yeah, I totally agree. And I think it raises an interesting possibility about something called the sustainability paradox that's sometimes spoken about in SETI. So, maybe the easiest civilization to discover is one that's in the greatest disequilibrium with itself, which means it's the least sustainable. So the easiest civilization set would be one in like
at the
nuking
most
themselves. Right?
dangerous pivot point.
Yeah, the most violent and ecologically damaging civilizations would be the easiest ones for us to see because they're in the most disequilibrium with themselves. And the hardest ones to see would be the mature ones who figured out this is not sustainable. They start recycling everything. They start using solar powers and everything. They figure out a way to basically be in balance completely with their planets. This is sometimes called the sustainability paradox because it means we can't really detect those civilizations. The more invisible they become, Arthur C. Clarke had this quote that's like, when any sufficiently technologically advanced civilization is indistinguishable from magic. And then Carl Schroeder, another science fiction writer, said, any sufficiently advanced civilization is indistinguishable from nature.
Yeah.
Because once they get so advanced, you won't see them anymore. They will just look like they blend into the stars.
Yeah, one thing I just want to, if I could.
Please.
An idea that we've been working on. So I've been the principal investigator on NASA's first grant to do technosignatures, to investigate technosignatures. And one of the ideas we've been playing with for a while that we still haven't written the paper on is the idea, though, of service worlds, right? So the unit of technosignatures should maybe not be planets, but should be planetary systems, right? Because the distance between the stars is so vast that it may really be hard for a civilization to really marshal the effort and continue the effort to do that. But planetary systems are relatively easy to settle, right? We've already sent probes to every kind of solar system body. And so it may be that what we should be looking for are airless worlds, right? Where you can put your technology, you can put your industry, you can put whatever you want on it, and they, and that would be really visible.
Like a trash dump, basically.
A trash dump, right? Or an industry, right? That's one way. But imagine taking Mercury and covering it with solar panels in order to, to do industry put your industry on Mercury. The glint from those solar panels would be visible from hundreds of light years across. So maybe that's like the better way of thinking about it, these idea of service worlds rather than messing with your own biosphere.
I do think it's really interesting that a number of times in your responses, you've come to the idea of this sort of dangerous inflection point, this dangerous bottleneck, this dangerous inflection point. That is the idea of the Great Filter, but this isn't theoretical. This is what we're facing. We are the only species on Earth that is capable of self-annihilation. Whales cannot self-annihilate. Come to Wales next year. But they are an intelligent species by many measures. So what we really mean is technologically sophisticated, able to manipulate our environment. Is that inherently hazardous? I think I'm going to ask this two ways. Is it inherently hazardous? And another way is intelligent, technologically advanced civilizations evolutionarily favored or disfavored? I think they're similar questions.
Yeah, I mean, it seems like it's an inevitable double-edged sword. The greater your capabilities to affect your environment, the greater your capabilities to weaponize those same technologies to cause damage. And, we talked about climate change as one of those possibilities, but it's certainly not the only threat. I mean, as you said already, in the 70s, it was nuclear war. And I think these days, a lot of people are concerned about AGI and AI sort of roaming around. And that might be an even stranger reversal, right? Because it might not be the sort of Terminator scenario of robots taking over, but maybe just we get dumber over time, right? I think that's probably the most likely outcome of these AI things. We just start offloading all of our intellectual labor to them, and we forget how to think because we just don't bother doing it anymore. And as a teacher, we're both professors. We see this already in the classroom. It's something I worry about.
Woo, you're going back in September.
Yeah, we've got that to come up. It gets worse every semester at this rate. So, I think there's many threats, and it's this mirror aspect of every time we come across some new capability, it's inevitably going to be something that will pose a threat to us.
Mm-hmm.
Yeah, I think we are in this, I always like to say, every generation thinks it's, at the turning point, but we actually are, right? And particularly our kids are. And this is a pivotal moment. And that's why it's the fact that we both have evolved this capacity to affect the planet, that we have become a truly planetary species for the first moment. And at that exact same moment, we've gotten to the point where we have an actual astrobiology. I don't think it's an accident that those two capacities emerge at the same time. Because in some sense, I think it's the astrobiological perspective that is actually the thing that ultimately is going to save us. We are, because there's no way we're going to get to what I like to call a mature technosphere, a technosphere that doesn't subvert its own conditions for existence, unless we sort of develop a sense that, oh, right, we're on a planet and planets have rules and you can't mess with those rules. And so this beginning of understanding that the universe is teeming with planets and that understanding how life affects planets as we do this search, I think if we're going to make it, these things are intertwined.
Can I just dovetail one extra thought here? And that's that we haven't done the experiment of apocalypse, thank God. That's not happened. So just to say we don't know what the outcome of that experiment is, I think we tend to assume human extinction, eradication. But humans are pretty persistent. We cover the entire planet. We're even in space, and soon we may be on Mars. We may be less like a gift to the planet and more like an infestation. It's kind of hard to kill all the rats in New York City. It's pretty hard to get rid of all the cockroaches in the street. And humanity, we tend to think we're this glorious thing, but we might just be the pest on this planet. And it might be very difficult to actually ever get rid of our presence. And so maybe you knock us down to 1% population, but we're just going to swing back again and be there present once more.
Can I offer a slightly different metaphor? But I agree with that. And that's a good metaphor in a certain way. But the other metaphor is like, look, we're just what the biosphere is doing right now, right? I mean, the Earth's biosphere, we are just part of the biosphere. The Earth's biosphere has run a lot of experiments, right? For a while, it was like prairies, like, hey, here's this new thing called grass. Let's see what happens with that. And then there were dinosaurs. It's like, yeah, giant lizards. The idea of a technological civilization is really, we should, recognize we're just an experiment the biosphere is running. And if we don't make it, the biosphere will, hey, thanks for the global warming. I'm going to use this now for the rats, But another, even more important, is like, if we go to Mars, it's not us going to Mars, it's the biosphere going to Mars. We're the agents of the biosphere, like a green tendril reaching out that eventually could settle the entire solar system so that, in 500 years, the solar system is teeming with all kinds of life. So, a mirror of that metaphor is that we are the biosphere's agents for making more creativity, more innovation, and more the beauty of life.
Mm-hmm.
More artistic take.
Well, we still aren't doing that well compared to the dinosaurs, which may have been, pea-brained, but roamed for hundreds of millions of years quite successfully. And we're not taken out by themselves, right? We're taken out by some ill-fated asteroid. And so I guess that leads me to another question, which I've been confused about reading both of your works, both your technical papers and your Cool Worlds podcast, which is excellent, I recommend, and your wonderful book. Are we early or late to this party? Both a civilization and in terms of the emergence of life, is evidence of what happened on Earth a signal that life is easy, because we came very early? And as a civilization, are we early or late in the scheme of things?
Yeah, I've thought about that a lot. The chronology of Earth's history is kind of the only data point we have. And when you look at the history of the Earth, it seems like life started extraordinarily early. So the oceans probably formed about 4.4 billion years ago. The planet itself, 4.5 billion years ago. And just 200 million years after the formation of the oceans, you have the earliest evidence for life on this planet. So it probably even started, of course, even sooner than that. That's just the earliest evidence that we have thus far. So that's extraordinarily quickly. It seems to happen as quickly as it possibly could. And that does give me optimism that at least if you had the identical conditions, which is a big caveat, we don't know if those conditions are everywhere, but if you had the identical conditions and you reran the experiment, yeah, I think you probably would end up with repeats of this success. In terms of humanity's own arrival, though, we are pretty late on the clock. So the Earth has about 5.5 billion years of habitability for complex life, and there's only less than 1 billion left. So we are in the last chapter of the Earth
of what
story.
the Earth can endure.
And I think that's an interesting data point. I mean, it proves that at the very minimum, that intelligent life is not some simple process that can happen within a few 100 million years. It takes a long time for this process to happen. Maybe there are some stars that have such brief lives they can never get there. On the other hand, there are stars like M dwarfs, which seem to have lifetimes of trillions of years, and yet we don't live around an M dwarf. They're far more common than sun-like stars. They live for far longer.
Very small, very red, stars.
The most
Yes.
common kind.
The most
And they're
common
the
stars
most common,
in the
and
universe.
they live for a very long time,
And I think I call it the red.
much longer than the sun will.
Yeah, I think it's a real mystery why we don't live. They actually seem to have more Earth-like planets around them. They seem to have, they outnumber Earth, sun-like stars by about 7 to 1 or something, and they live for hundreds of times longer than the sun. So they seem to have a lot going for them. I think the fact we don't live around one is actually kind of interesting, and maybe hints that there are, as Adam alluded to earlier, maybe some fundamental problems that might prohibit life beginning on them. So those are like the soft data points we have from the chronology and our own existence to try and give clues as to what's possible.
I just want to, because we just did a paper on this led by Dan Mills, which was, this was, what was so great about this paper is we, as, it was two astrobiologists and then earth scientists who really work with the history of, that's what Dan Mills, he's I think it's called a geobiologist. And so there's been this argument about like, why did life take so long? And there's something called the hard steps model, which has been used to argue. That's actually where the great filter idea came from. But with working with Dan, what we saw was actually, we're not early or late, we're exactly on time. Because what could happen is that the Earth, this is the most beautiful idea to come from the Gaia theory, right? If for some of you are familiar, that the Earth and life co-evolve. It's not just life, it's not just the planet, they co-evolve. That the planet has to go through its own evolution, right? You have to have plate tectonics at the right time. And then life has to affect that. Life generates an oxygen atmosphere. And all of these things, the planet itself may have billion-year evolutionary timescales with life, and that windows open up, right? So there's a certain way in which, like, you could not get intelligent life before there was an oxygen atmosphere, a pretty, rich oxygen atmosphere. That didn't happen until maybe 500 million years ago. So there was no way to get intelligence, 2 billion years ago. So this is a really different idea, and I really just love this paper for what Dan did with it. So it's quite possible that we arrived, as soon as the window opened up, it wasn't that long before intelligence showed up. So that's a different sort of perspective on it.
So how surprised are you that there isn't other life in our solar system? I mean, we have lots of moons with waters. We don't have exactly the same conditions. There's this whole Goldilocks obsession that we're perfect and everything has to, but there are conditions that are absolutely reasonable, if not on other planets, on moons. Do you think we have yet to discover life in our own solar system, and are you surprised it isn't more evident?
Yeah, I mean, we don't know that there's not life in the solar system. There could very well be. Certainly on Mars, it seems a hostile environment right now, but in its past, there's clear evidence that it had liquid water in the past. We've even seen liquid water on the surface in modern times, but it's this kind of very high saline, kind of briny water, maybe not the best place for life. But certainly in the past, it should have had episodes where it had extensive bodies of water. So that seems very promising. Venus is maybe harder to imagine being a habitable environment, but as we've heard, people have claimed life on Venus, at least to a certain degree. Maybe in the clouds, you might imagine it being more temperate, and maybe something could survive there. But again, we don't know a lot about Venus's past. It is possible that in the deep past, it had a period where it was more habitable. And then, of course, Europa and Enceladus, we just don't know. Titan, we really don't know. So I think there's just a huge amount of, these moons in the outer solar system. We just don't know. In terms of moons, I mean, my favorite counter-fictional story, I wish someone would write this story, would be imagine if our own moon was just a little bit more massive. Because it is a freakishly large moon. Yeah. If it was just a little bit more massive, it could have held onto an atmosphere. And then when Neil Armstrong set foot on that body, he could have potentially have done so in t-shirt and shorts, right? He could have just walked out in his beach sandals. Right. And imagine how different human history would have been if that was a habitable globe sat right next to us. And it probably in the past, I suspect one of the other planets was like that.
Right. And I think the moons, for people to understand that, because this was really a radical discovery, the large planets, the gas giants, have these moons around them that have deep oceans. So Europa has more liquid water on it than Earth does. But it's probably like 100-kilometer deep ocean, but under 10 miles of ice. So we just have no way of knowing what's under 10 kilometers, I think it is, of ice. And the same thing is, we've seen water shooting out of Enceladus. So those moons may be places where there are incredible ecosystems happening right now.
I'm conscious that I promised to get to some of the questions that people submitted, and I can only probably do a couple, but I do want to point out that we're not 100% certain that we didn't come from somewhere else. We know that the Earth didn't have water when it formed, and water was deposited here through bombardment from asteroids and bodies that were traveling around. I mean, could life have come here from somewhere else? Could we be the extraterrestrials we seek?
Yeah, we could be Martians for sure. But people often invoke this idea, certainly in the solar, there's two kind of panspermies that I like to really delineate between each other. There's panspermia happening between planets in the solar system, which is absolutely plausible and feasible because we know tons of material transfers between them. We discover rocks from Mars and the Antarctic all the time. But then there's the much harder problem of could life have come from another star system altogether? Now that's asking life to somehow survive a ride in vacuum for potentially tens or even hundreds of millions of years for these journeys. That's very difficult to imagine something surviving that long. And plus the impact rates are far less. So in the solar system, I'm open to that idea. I don't know what it does. I don't know how useful it is because it doesn't sort of prove that life is therefore everywhere. It just means that life started a little bit sooner than we thought and we're connected to that. So it doesn't really move the needle for me, but maybe you feel differently.
No. Well, first of all, just even whenever I heard, I first heard of panspermia, I was like, ooh, do I have to say that? Yeah, I do think there's the possibility, and looking at the papers, especially after the discovery of Oumuamua and such, I think there is some possibility that there's like an interstellar network of life being exchanged. I mean, it's sort of out there, but I don't think it's beyond the realm. Now that we know, we've seen stuff actually passing through the solar system that came from another star system. Potentially it's possible, which would be really interesting. But it's still, no matter what, it still pushes. It doesn't solve your problem about how did life start.
I just wanted to point out that this was one of the deep field surveys of galaxies, and we've been talking about our own galaxy and interstellar travel and planets in our own galaxy, but every single object we see in the sky is itself a galaxy. We have not even begun to contemplate intergalactic travel because we're talking about millions of light years away. So even traveling at the speed of light, from our frame of reference, it taking millions of years. When would we like to start to talk about that?
I think SETI people are interested in this. There is an idea of extragalactic SETI, of thinking about looking for life in these other galaxies. And this gets into this idea of sort of Kardashev scales that you sometimes hear about. So the idea is that, a sufficiently advanced civilization could basically gobble up all the power from their star and eventually maybe even all the power from their Sagittarius A star, their supermassive black hole in the center, and all the stars in their galaxy. So you'd end up with these galaxies that get transformed and they look different somehow. We don't exactly know how, but they would look somehow different. And people have looked for this. Jason Wright, one of our colleagues, has surveyed 100,000 nearby galaxies to see if any of them look funky, and none of them apparently do. And that's a pretty tight constraint, because I said earlier, maybe there's 99% of galaxies are colonized by crazy aliens, and we would necessarily live in the one where it didn't happen. But this is decoupled from that argument. This is now a completely independent sample from us. So I actually think extragalactic SETI has a really bright future of putting some really interesting statistical constraints on what life can do.
It does, though, assume that aliens build Dyson spheres and do this. And that's one of the things when we're thinking about in this paper about pushing back on the Fermi paradox. First of all, it's not clear that really is possible. There's this extrapolation of course, technology just goes on forever and you can do whatever you want. And there really may be limits to what technology can do. We've just lived in this brief couple of hundred years where human capacities, energy harvesting capacities have been exponential. But there's no reason that's going to continue. So the idea that, I'm just skeptical of these science fiction stories where we can, reform, do galactic engineering. I'm like, that's a particular moment.
You know what Freeman Dyson, namesake of the Dyson spheres, he used to say, though, don't worry about, maybe I'm paraphrasing heavily, but don't necessarily worry too much about how likely a certain thing is. Just worry about whether you can detect it. Just look for what you can actually do observational experiments on. So this is actually an experiment we can do, and then we can argue about how likely or unlikely it is, but it is science. We can actually do that.
So I have a couple of questions from the audience. I'm synthesizing quickly reading the submissions. One question is about AI. And let's say there was another alien civilization and this kind of advanced technological evolution was inevitable in a Darwinian sense. Would they also develop the same kind of an AI? Obviously, I don't even think we can imagine consciousness transferring in the same way. We have animals on this planet that we know operate very differently, like the jellyfish, or the hive mind of certain insects. But even so, if we're talking about technological advancement, will they also have an AI, and will they use that to make their way here? Or will we make our way there?
Well, first of all, I just want to put in my pitch that I think where we are with AI right now, the hype over the kinds of AI we have now is insane. And the idea that like the LLMs that we're using are close to being conscious, or that AGI is like next week, is just, yeah, I won't use profanity, but and because part of it, and this actually goes to a question.
Do aliens swear?
Zorp glib globin glibin. We don't, there's this profound misunderstanding about the nature of conscious, what it means to be conscious, what it means to be alive from my perspective. These are very reductionist models that people have in their heads. And one of the things that's beautiful, I think, about astrobiology is, again, it forces you to go all the way down deep and ask these questions about what does it mean to be sentient? And I'm not saying that it's impossible for sentience to appear in silicon, but like, we don't even know what makes us agents. We are autonomous. All of life is an autonomous agent. We're not even close to understanding what that means, the weird loop that involves. So I just wanted to put that pitch in. But I do think that in general, the use of machines, the development of machines is part of the energy harvesting. And I wouldn't be surprised if, that AI, that many technological cultures develop AI, whether or not consciousness is possible, so that they're independent and completely autonomous. I don't know about that. I think that's open.
Yeah, I mean, it might be like offloading intellectual labor, not necessarily into silicon machines, but maybe into some kind of genetically programmed machines or something. Like, it's not necessarily going to be what we imagine as AGI. But, I like the Spock quote, infinite diversity and infinite combinations. We can't have like a monocultural fallacy, as our colleague Jason Wright likes to say, where you just imagine all aliens will do X. Like, they're going to do a bunch of different stuff. There's going to be some that are into sustainability. There's going to be some that are super aggressive. There's going to be some that are technophobes, some that are technophiles.
The bonobo and the chimp.
Yeah, there's gonna be a lot out there. So I think it's really a numbers game. If like you really did have 100 billion living worlds, which is the most optimistic you could possibly imagine in our galaxy, then it just becomes a numbers game as to how many of those then have life on them and intelligent life and eventually develop these AGIs. And that's, I think, coming back to this original point of like, why don't we see anybody? Because you would expect with enough monkeys on the typewriter, you would start bashing out some interesting prose. With enough rolls of the dice in 100 billion samples in the galaxy, sure, you probably would expect somebody to develop an AGI somewhere.
I could talk to you guys all night. I'm sure the audience would love it too. I just want to do one last lightning round, 2 questions. In the next 50 years, now I am asking for odds, not beliefs so much. Just quick answer, do you think we will actually discover life on another planet, even if it is just a grand biomass of bacteria or some microbe?
Not with scientific consensus.
Ooh, amazing. And you, Adam?
I just can't answer that. What I will say for sure, though, is that unlike the last 2,500 years, we're now finally past just the opinion stage.
Is it possible we would discover life in 5 years? Possible.
I think biosignatures, I think we will have data for sure in the next 30 years, like when we get the Habitable Worlds Observatory, though it may be China that builds it, not us, because of what's happening in science in this country right now. Once there is the Habitable World Observatory, then we're going to have actual data. And we've already seen it. We're going to have actual data where we can have actual arguments.
If Adam. NASA's funding is not looking too good right now.
Yeah, that's what I'm saying. That's why. But somebody's going to build it, even if it's not, the United States.
Okay. Oh, sorry, I didn't mean to interrupt you. Just to go really out on a limb, do you think we will discover evidence of alien civilizations in our lifetimes, meaning next 50 years or so? Let's give the audience 100 years, because we've been doing a lot of longevity episodes. So. Next 100
Yeah,
years.
my punt on both these is probably a no, and it's really just a guess though. No one knows the answer to this. I'm just looking at the analogy of exoplanets and the history of discovery. The first claim of an exoplanet was in 1855. 1855. And it took more than 140 years before we had the first one that everyone agreed was real. So sometimes discovering something new takes a long time to develop the expertise and capabilities to actually pull that off.
And then it accelerates.
Yeah.
Then it accelerates a lot. What do
Yeah,
you
so I
think?
would actually say, okay, so 100 years, I'm going to be optimistic. I think we will have evidence for biospheres because I do think that I think it is easy to make a biosphere. So I do believe that within 100 years we will have found a planet that has a plausible, biosignatures, and we will have done enough extra. Because if you find one, I said that won't be. Scientists are going to beat each other up for a while, but then you'll build even more powerful telescopes and more powerful telescopes, so that after 100 years you'll be in the position where you'll have a pretty strong consensus. There's disequilibrium going there. Civilizations, I kind of agree with David that civilizations may be much rarer. So I don't know I think 100 years might be optimistic.
Well, fascinating. It's such a pleasure to talk to both of you. We're going to talk a lot more, I'm quite sure. I hope everyone will join me in thanking our guests, and also please join us for the book signing after. Thank you so much.